Nikos Lymperopoulos. I'm a project officer at the Clean Hydrogen Partnership or Joint Undertaking. I am a mechanical engineer, so very happy to be opening a workshop of geologists mostly. And I follow projects related to green hydrogen production. So it's mostly large electrolyzer projects that I follow, and Project HyPSTER does include such a component in the value chain. Hence, the project was assigned to me, and I'm really excited to be following this very important project. So, what is the Clean Hydrogen Joint Undertaking? Well, it is a public-private partnership between the European Commission, which is the public part, and European industry and European researchers, which is the private part. And its aim is to facilitate the transition to a greener EU society through the development of hydrogen technologies. We were launched in 2021, but we are a continuation of the Fuel Cells and Hydrogen Joint Undertaking, again a PPP, a public-private partnership, that ran from 2008 to 2020, so over 13 years, and provided a combined support of more than 2 billion euro to European researchers and European industry, supporting 287 projects. We provided 1 billion, and the participating partners an additional 1 billion. Now, the Clean Hydrogen JU was established, as I mentioned, in late 2021 and was provided 1 billion euro, but for only 7 years. So you can see that the support to the sector is now much higher. We are governed by a governing board and have 2 advisory bodies. And recently, an additional 200 million euro were granted to the Clean Hydrogen JU in the context of the Repower EU plan. And this is aimed to support just the creation of hydrogen valleys. So our research and innovation activities cover renewable hydrogen production, hydrogen transmission, storage and distribution, and end-use technologies that we will see in more detail in a while. The main objectives are to support the implementation of the Commission's hydrogen strategy, to stimulate research in the sector, to strengthen the competitiveness of the EU clean hydrogen value chain, and of course the bigger picture, to contribute to the EU climate targets for 2030 and 2050. Very briefly, what is the EU hydrogen strategy? This was launched in July 2020, more than 2 years ago, has 3 phases. Phase 1 is till 2024 and aims to install 6 gigawatt of electrolyzers producing renewable hydrogen, producing 1 million tons of renewable hydrogen. And this is the easy market, let's say, to displace grey hydrogen in industries that already use hydrogen. Then, in the second phase, 2025 to 2030, the aim is to have installed 40 gigawatts of electrolyzers to produce renewable hydrogen, producing 10 million tons of renewable hydrogen, which has been doubled if you look further down in the Repower EU plan. So the target is now 20 million tons, 10 million to be produced domestically in the EU, and 10 million tons to be imported in the EU. This time there will be new applications, like in the steel sector or in transport sectors. Hydrogen will also be used for electricity grid balancing purposes. Hydrogen valleys will have been launched, and there will be also cross-border infrastructure and regulations. And then phase 3, between 2030 and 2050, its hydrogen technology would have matured and the market would have matured, synthetic fuels, etc. will all be available, and there will be an open international market. Now, to support our role in realizing this, these are the research priorities of the hydrogen JU that we mentioned previously. There are 3 pillars: hydrogen production, at the end it's hydrogen end users, and very importantly, to link the two. So if you produce from renewables, these are stochastic, while some of the end users could be users that require a constant feed of hydrogen. If you are an industrial partner in a steel plant, you need constant feed. So you need to store, you need to distribute hydrogen, you need to store large quantities of hydrogen. Hence, item 4 in the middle pillar is large-scale storage. In the past, this was a clear picture. We were a one-stop shop where anyone involved in hydrogen and fuel cells would know, let's go to the fuel cells and hydrogen joint undertaking. Today, it's a much more complex picture. So as we go from research and innovation to demonstration and deployment on the right, there are now many players, mostly in the use of hydrogen. So the clean hydrogen JU will still be, you can see it in the middle, responsible mostly for green hydrogen production and hydrogen storage. And for the uses of hydrogen, there will be, on the left, there are additional joint undertakings like clean aviation or waterborne. So we developed a fuel cell that will go into an aircraft to be supported by clean aviation, or to a ship to be supported by the waterborne JU. Or the new electrolyzer will go to the steel plant. The steel plant modifications will be supported by the clean steel initiatives. And to the right-hand side is the various commission services that support the deployment, large-scale deployment, like the Innovation Fund or CEF. Focusing on the second pillar, large-scale storage, you can see some of the objectives. We are obviously addressing above-ground storage solutions, to improving them and demonstrating them, but also very relevant to this workshop is to validate the performance of underground storage in different geologies, to identify better materials, encourage improved designs, and to demonstrate large-scale underground storage across various media, hopefully at low capital cost. And I can tell you that this coming January there will be a new call for proposals, and there is a topic on a large-scale demonstration of underground storage of hydrogen. My last slide is a summary of the projects we have supported related to hydrogen storage in stationary applications. So there are more projects related to hydrogen storage in transport, in vehicles or ships, covering gaseous hydrogen storage or liquefied hydrogen storage. But these projects are stationary. So in relation to underground storage, our first project was HyPSTER, 2012 was the year of the call. That was a study with some interesting results, a rough estimation of an additional cost to hydrogen of €0.5 per kilogram if one was to store hydrogen underground. Then there is a long gap and come to 2020 where we supported 3 projects. HyPSTER is the bigger one, is a demonstration project, innovation action as we call them, and we will be hearing more clearly of this project today. And then projects histories and HyPSTER. These are research projects, and I think they are focusing on porous media storage of hydrogen. It's mostly laboratory scale studies. And on the right-hand side, we have supported liquid organic hydrogen carrier projects, mostly for distribution, but also it's a kind of storage. And storage in metal hydride tanks, Project Eden in 2011, that was a high temperature metal hydride tank, and the still active project HyCare, which is indeed for storing 40 kilograms of hydrogen in pilot application. And with this, I would like to thank you for your attention. I'd like to wish you a success in today's workshop. I'm really sorry I wasn't able to make it to listen to the interesting presentations and visit the city of Lyon. I will try and stop sharing from my end. I hope that worked as well. So, Muriel?
Yes, Pierre?
Thank you, Nikos. Thank you to the Clean Hydrogen Partnership for your support in this HyPSTER project, which is very valuable for us. Thank you also to our partners that have been working with us. They have been working for the call for proposal, and after they are working with us to deliver the project. So perhaps you do not know all of them. So there is Armin. I don't know if there are some representatives of Armin here. Okay. There is École Polytechnique. Yeah. Accelera. Okay. Brouard Consulting. Element Energy. Equinor. ESK, our Danish colleagues. Ineris. Innovin. Okay, thank you all to be here. Also, I would like to thank you, our guests, for their presence. So I'm not going to present all the guests, but I'm sure you will make it during the pause at and around the coffee. In particular, those who will take part in the roundtables, the guests that will take part in the roundtables, the institutional actors. There will be industrial champions also, and there are also some investment corporations. So very happy to see all you here, because you are essential for the development and the implementation of new hydrogen infrastructures. So if we go back a little bit on if we concentrate a little bit, on the current and geopolitical energy context where we are. So Storengy and other operators are more than ever mobilized during this crisis to ensure the security of natural gas supply. And European cooperation is required and is a must in order to succeed in this very big challenge. In terms of the climate context, you all face the acceleration of extreme events. We can see these days in Florida what happened, but there are also this summer, very extreme summer in France with this hot temperature, droughts, heat waves, fires. And we are now directly, these weather conditions are now directly impacting our lives and our energy system, and push us to make a transition in our activities in order to achieve the carbon neutrality. One of the answers, which will not be the only one, will be the production of renewable power through wind and solar mainly. And this production is expected to grow significantly in the coming years to decarbonize our energy mix. However, intermittencies generated poses great challenges for their integration into the electricity grid. Sector coupling between gas infrastructure, electricity infrastructure, flexible long-term storage are key to overcome those challenges and eventually increase renewable power share in the energy mix. One of the most promising solutions from our point of view is transforming surplus of renewable electricity into hydrogen by electrolyzing water and coupling this hydrogen source with a fast cycling underground hydrogen storage. UHS offers indeed the possibility of strong massive amounts of energy over the long term while remaining flexible. Daily to yearly discharge time. The European Commission, as Nikos has presented, forecast an annual consumption of 20 million tons by 2030, which is huge. To give you an idea, it's 40 gigawatt production within Europe. 10 million tons will be imported. In this base case scenario, we estimate 78 terawatt-hour of hydrogen that will be stored, which will be only 10% of the total hydrogen consumption. by 2030. In order to foster the emergence of renewable hydrogen, to ensure security of supply, as we are doing now for the natural gas, and to minimize the total cost of the operational chain, a massive and flexible hydrogen storage solution must be developed. Underground storage of natural gas is mainly carried out in 3 types of assets. I think most of you know it: porous rocks, depleted fields, and salt caverns. Given the time required to repurpose caverns and to create new caverns for hydrogen storage, project must be launched right now to be ready by the end of the decade and cover the market needs. 6 underground hydrogen storage sites have already been in operation since the 70s in the UK, in the United States, showing that hydrogen can safely be stored in salt caverns over decades. Nevertheless, these storages were designed as strategic backup and thus are not cycled, while a storage aiming at offering flexibility to integrate the renewable production of power, renewable hydrogen, should be cycled 6 to 40 times a year, according to the studies we can see. So what is HyPSTER? HyPSTER is the first industrial-scale pilot of hydrogen fast-cycling storage in salt cavern, with 100 cycles of 3 tons of hydrogen that will be performed in 3 months. And this will be planned as soon as 2023, so next year. The project team will also evaluate the economic feasibility for future implication across the European Union and perform an assessment of risks and environmental impacts of H2 storage in salt cavern and provide also guidelines for safety, regulation, and technical standards. The HyPSTER project is currently being implemented in this area, in this region, Auvergne-Rhône-Alpes, at 100 kilometers from Lyon, in Étré storage site near Bourg-en-Bresse. Storengy currently operates 20 salt caverns there. We have been operating since 40 years there. It's the first salt cavern storage site in France, the 5th in Europe. Underground hydrogen storage is an asset for strengthening the energy independence of territories, supporting national and regional policies towards carbon neutrality, in heavy mobility, and in industry first. It is also a tool that provides a renewable, local, and competitive energy. Because of its pioneering nature and the technical lessons that will be learned from this experiment in industrial conditions, the HyPSTER project is a fundamental, an essential building block for the hydrogen sector. Development of this new H2 infrastructure is currently in its exploration phase. Strong ties are required between infrastructure operators, not only French infrastructure operators, but also European infrastructure operators, TSO, SSO, DSO, on a European scale, because we have all the same question and the same constraints. What are they? We need to build an integrated and optimized vision of the infrastructure needed for the H2 economy to take off, to scale up, and we can maximize the chances only if we collaborate and we share risk and make the sector emerge. So the main goal, you will have understood that the main goal of today's workshop is to disseminate the result of the HyPSTER project and help various stakeholders involved in this underground business, in this underground hydrogen storage business, in order to strengthen our relationship and share our needs and our difficulties. So please, let us meet each other today. Let us discuss, let us questions and analyze the result of this HyPSTER project and have a fruitful collaborative together session. Thank you for your listening.